Piecewise functions is the part of this lesson. Please make sure you're taking good notes as we're going through this lesson. First thing you should be doing is that you should be graphing these three equations on the same coordinate plane. You have done this before. It's nothing new. So I'm going to graph the first one, y-intercept of -1, slope of 3. And I'm going to graph this line right here. The next one is y equals 4. That's a horizontal line. I'm going to graph it right here. And the last one is in point slope form. The point on the line is 9, 3. The slope is -1/2. So start here at 9, 3. That's this point over here. And a slope of -1/2 puts it somewhat off of the coordinate plane if you went down and to the right. So I have to go up and to the left. Now, if I look at these three equations collectively, they are not a function. But what I'm going to do is I'm going to use pieces of this function. So I am going to use this function, this piece, until I get to that point right here. Then I'm going to use this function till I get to this point. And then I'm going to use this piece of it. And now this red line is what we call a function, passes the vertical line test, but it's made up of different pieces. And again, I'm using that first line that we graph for all of the x's up to and including x is less than or equal to 1 2/3. So I use this, notice here all of my x values, and I'm using those x values until I get to 1 2/3. I'm using this piece right here, and it's determinant on the x values. So for the x values from 1 2/3 all the way up to 7. And this last piece I'm using in the function when the x values are greater than or equal to 7. This is helping me define when and where I'm using the pieces. Now, one thing I'll talk to you about is notice this is a not equal to and this is an equal to. You cannot have a piece used for two different functions. What I have created for you so far, the domain values for the function are those that are part of or including everything on the real number system. The range values have a limitation. The range values only go up to 4, and everything else for the range is less than or equal to 4. This is what we're going to be working on, is reading and writing piecewise functions. All right, if I look at this graph that I have right now, it's made up of a couple pieces. I'm going to add a couple elements on there so we can read this a little bit differently. I'm going to put this as an arrow here and a closed circle here. I am going to put an open circle on each of the ends of the blue line, and I'm going to put the red one as a closed circle, and I'm going to put a closed circle for the green. So this right here will have a closed circle on either end. That is significant to us. If I asked you to write the function, what is the equation? What are the equations to make up this graph? I'm going to start with this piece right here, the red piece. Now we write this as f of x is equal to, by the way, you don't have to use f, you can use any letter you want for your function, but it's made up of three pieces. So I'm going to put the three pieces in here, and then I'm going to tell you when I'm going to use them. The first piece is the red piece, and if I look at that line or try to graph that line, and if it were to continue, there is a slope of 1 and a y-intercept, notice if we continue this on, of 4. So I'm going to say 1x plus 4. I don't write y equals because this is the y. Y equals this. And now I'm going to say I'm going to use that if or when the x values are less than or equal to 2. So I'm only on this line all the way up to 2, or negative 2, I'm sorry. After that, I'm going to a different piece of the graph. The next piece, which is the blue piece, the slope of that line is 2, and the y-intercept, if you continue that, would be at 6. And I'm going to use that piece specifically for the x values that are between -2 and -1. Now there's an open circle here, and you will be told on your notes if there's an open circle or closed circle. But so because it's an open circle, this is not equal to. The last piece of this function is y is equal to 4. And again, I don't write y equals, that's just a piece, and I'm going to use that piece if the x values are greater than or equal to -1. This is the graph, this is the function to write that particular graph. If I ask you about the characteristics of the domain, what domain elements I'm going to have? Well, I have all of the x values I can find in the graph until I get to this point. And then I don't have any more x values. So the x values are less than or equal to 5. The range values, you don't have every range value. They start up here at 4, and then I can find range values all the way to -infinity. So I'm going to say the range values are such that they are less than or equal to 4. You could write that in interval notation. It would be from -infinity all the way up to 5, bracket, or -infinity up to 4, bracket as well. If I say to you, let's graph this function. Okay, the first part of this, I'm going to use this graph right here, that piece. So I'm starting at -1, and I have a slope of +1. So I'm going to use this function, but I don't want all of it. I only want this when the x's are less than or equal to 3. So I'm going to use this point, this piece of the graph right here. I don't want anything beyond it because this is where 3 is at. So we'll only want the x's if that's the case. The second part of this says you have -1, which is horizontal line. Y is equal to -1. And this occurs when the y values are greater than 3. So I have an open circle here at 3, and I'm going to have an arrow going this direction for x values greater than 3. If I ask you for the domain after graphing this, if I have x values less than or equal to 3, I'm going to use this function. And if they're greater than 3, I'm going to use that function. So all of the x values in the real number system are found in part of this graph. And the range values are such that when I graph this, the maximum range value I'm going to get is 3, and then I'll have all the range values below it. So I'm going to say y is less than or equal to 3. This line right here is part of less than or equal to 3. All right, let's graph this one. Please make sure you're graphing with me. So the first one says I'm going to have 2x plus 1, so I'm starting at 1 and I have a slope of 2. And I have to decide, as I'm setting this up, what part of the line am I going to use? And it says we're going to use the part of the line from where the x's are greater than -1. This got off a little bit, didn't it? So I am going to use from this point on. Now this circle right here, because it's not equal to, I'm going to have it as an open circle. The second part of this says I have this horizontal line at -3, and I'm going to use that for the values of x that are equal to -1 and less than that. So it's going to go this direction. So I have this piece, and I have an open circle and that piece. If I ask you, what's the domain of this function? What x values can you have? And notice these are all greater than -1, and I have the values over here that are less than or equal to -1. That would include every single x value possible. The range values are such that you don't have them all. And so we are going to write this another way. We're going to say you have the values that are greater than -1, or they are, in this case, -3. That is how you would write it. Those are your choices. If I want to write the function for this graph, I'm going to look at what the graph has and say, what are the equations and when am I going to use this? Well, this equation is y is equal to 7. And this equation looks like I have a slope of 2. And if I were to continue this and I want to figure out where would my y-intercept be at, it looks like it's going to be at 10. So this equation is y equals 2x plus 10. So now I'm going to put this into function notation. F of x is equal to, well, it's going to equal 7 if the x's are greater than or equal to -4. It's going to equal 2x plus 10 if the x's are less than -4. When I look at the domain of this particular function, again, the domain is going to include all real numbers. And the range values are such, there's a break in it again. We will have range values that are less than 2, not equal to it, or they're going to, you could say that the y's are equal to 7. You don't have to have the y equal to, you can just have a 7 in there. All right, the next type of function is called a greatest integer function or a step function. And when you look at the step function, there's this kind of different notation. It's a double bracket thing. It's not an absolute value, so be careful how you're writing it. But when you're looking at the greatest integer values, you're looking at something where it creates a step as you're going. What is the greatest integer that you have? And so it creates this open circle here, close, idea of a step function. Let's talk about that. Like how would, wait, no, what happened? So if I'm looking at the greatest integer, for instance, let's say I have negative, let's start with 3.1. The greatest integer value that you would have would be 3, and it's going to stay consistently at 3. It becomes what we call a step function. So this is going to open itself up here, we'll close it, all of that stays consistent, open and then close here because it jumps. You're like, when would I ever use that? What? Well, let me give you an example, and that might be easier. If I say to you that you're going to visit a psychologist and they charge for $85 per hour or any fraction thereof, and I ask you to draw a line to represent what's going on, you would have something like the following. First, you're just in the first quadrant. It doesn't make sense to leave the first quadrant. And from 0 to 1 hours, I'm going to put in $85 here. They're going to charge you minute you get there all the way up to 1 hour. I'm looking at my inequality symbol. And then, hang on, right here, I meant to put it at that point. And then at $85, the price jumps again. And for the next hour, from 1 to 2 hours, instead of being $85, it's $170. So the price jumps, and if you're there for an hour and a half, you're still paying $170 until you get up to 2 hours. And then again at 3 hours, the price makes a jump. So as soon as you get to the 2 hour mark, all the way up to 3 hours, the price is going to jump. So here we would have $255. And you can see how that would work. Mechanics, that's how they charge you. Somebody that's coming out to your house to do take a look at your furnace, and they charge you a fee or a flat fee just to make a look or a service call. That's how they do it. So it doesn't matter if they're there for 10 minutes or for 25 minutes, it's still going to charge you the same amount of money. Here is again a graph of what's happening. Okay, if you look at this one, the daily grind, it charges $1.25 per pound of meat or any fraction thereof. If I say to draw a graph that represents the situation, it cannot be linear. You should right away say, I'm going to exclude that one. It's gone. It says, again, the daily grind charges $1.25 per pound of meat or any fraction thereof. It's going to be $1.25. So this can't be it, because here you have a half a pound and you're not being charged anything. Now this one can't be the deal because you haven't bought anything, so you can't get charged. Your circle needs to be open there, so A should be the winner. You start buying meat and it's $1.25 per pound or any fraction thereof. So now you can say, if I buy half a pound, it's still going to cost me $1.25. You're saying, well, then why wouldn't I just buy the full pound? I don't know. You should. Absolute value functions are really a piecewise function. That's what it's part of. It's this piece of the function right here. If the x is greater than 0, you have this line right here. But because we're talking about absolute value, and the x could be a negative inside of here, you can technically have this function as well. So the slope then being -1. And so what we do, instead of writing this as this big long function, we say f of x is equal to the absolute value of x is equivalent to this piecewise function. All absolute value functions are going to have a V shape. In this case, the domain is all real numbers. You can put in anything you want for x, but what you're going to get out is something positive. So there's a limitation on it. So my domain, if I'm writing it in set notation, is a set of all x, such that x is an element of the reals. And my range notation is such that the y values are only going to be those that are greater than or equal to 0. Again, you can take a peek at that by making a table. So if you have the absolute value of -4, that's 4, and the absolute value of -3, that's 3. Absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, and then it's going to work its way up. Absolute value of 3 is 3, absolute value of 4 is 4. So when you go to graph this, here are the ordered pairs, and you can see how this is always going to make that V shape. We're going to graph it in here. The domain, I already gave that to you. You can also look at that in interval notation, so from negative infinity all the way up to positive infinity. And the range value, it can be equal to 0. So let's make this into a bracket all the way out to positive infinity. And again, there's no bracket on infinity. If I said to you graph this particular function, this is your absolute value one, and it's saying we're going to take that thing and we're going to have a y-intercept at 1, so the whole thing is going to get moved up. And if you didn't know that, you could make a table of ordered pairs and you could see what's happening. And I'm going to graph this function. So when I look at what the domain would be, again, the domain, you can put anything you want in for x, so it's all real numbers. And the range values are those such that y is greater than or equal to 1. You don't get any y values below that. Interval notation, you would write that range as 1 to positive infinity. For this one in interval notation, it's from negative infinity to positive infinity. You don't have to write it both ways. You can pick a way. If I ask you to identify what this is, it is an absolute value function. And notice this thing has been moved down a unit, but it's also been shifted right. So if you put some values in and you're like, which one is it? Put in 1 for x. And what happens when you put in 1 for x? You have the ordered pair 1, negative 1. Which one is going to produce that for you? It won't be this one. And it won't be that one, and it will be now one of these two. Which one of these two is it? You might be surprised to see which one it is. It's actually B. This is moving the graph to the right 1 unit, and this moved it down 1 unit. We'll talk about that in our transformation unit in more detail on Wednesday. Here's what your homework assignment is. You're going to need some graph paper in order to do this, or graph stickers, so make sure you keep that in mind.